Welcome to the Learn Smart Academy tutorial on spheres, hemispheres, cones and frustums. Before we get started, let's go through our checklist to make sure you've got pen and paper to hand in case you need to write anything down, a quiet space with no distractions, and then we're ready to go. So previously we have looked at cones and spheres in terms of finding the surface area and volume, and they do have to give you these equations in the exam in the formula booklet. But it's really good to get used to seeing them, so we're used to using those types of equations. And also we can logically start to break up spheres in terms of hemispheres and cut them in half, and also break up cones and form things like frustums. So we know how to find the volumes of these slightly different shapes. So just to recap on the equations that we have seen before, but we will be given, the surface area of a sphere, once we know the radius, is going to be given by 4 pi r squared. The volume of a sphere is going to be given by 4 pi r cubed over 3. And that information will be really useful when we come to look at hemispheres in a minute. For cones, I've actually added in, you'll see now, there's an L value here, which is the slanted height of a cone. And that's useful when we're looking at the surface area of a cone, because the surface area of the cone is made up of two things. It's made up of the circle on the bottom, so we can write in pi r squared for the surface area on the bottom, and then also the surface area of the bit that is wrapped around to form this cone around the outside. And it turns out that actually that is given by pi times r times L. Now, if we know h and r, but we don't know L, remember that L is given by, based on Pythagoras, it's the square root of h squared plus r squared, because this is a right-angled triangle. So that is the surface area of a cone. They might give you those equations, but you may have to use Pythagoras' theorem on a triangle within a cone question to find the value of L. Okay, the volume of a cone is given by a third pi r squared, so the area of the bottom, times h. So this time we don't have to worry about the slanted height. It is the vertical perpendicular height that is in the volume of a cone. So these top two are useful for hemispheres. These bottom two are useful for frustums, and we're now going to look at those examples. For a hemisphere, sorry about the wobbly line on the bottom here, it's quite difficult to draw it perfectly accurately. The area, or the surface area of a 3D hemisphere, it's not only made up of half a sphere, so we've got this half of a sphere part down around the bottom, but like cutting an apple in half, we've now exposed the core as well. We now have this extra circle up here. So not only do we have to half the surface area of a sphere, now the surface area of a sphere is 4 pi r squared, so half of that is 2 pi r squared. So we have that. We also have to add another pi r squared here because of this central circle, or the core, I guess, that we've exposed. And technically, those can actually add together to give us a nice round 3 pi r squared. So that is how we find the surface area of a hemisphere. It happens to be 3 pi r squared. Half of the 4, but we add another one because we've exposed the core. The volume, we just half the volume of a sphere. So a volume of a sphere is 4 pi r cubed over 3. If we're halving this, we can just half the number on the top. So we can half this 4 to give us 2. So we just get 2 pi r cubed over 3. So that will be the volume of a hemisphere. You don't have to remember these equations, but just remember how to come about them. So all the different areas we need to consider, or all the different volumes we need to consider. Okay, now frustums. There's a reason why I've written frustums underneath this diagram, because actually I'm going to add some stuff to the top of it. A frustum is a shape that looks like this, and it's actually made from two cones. One big cone and one small cone that has been cut out away from it. So if you imagine increasing this up here, keeping that going, you can see that it's as if we've cut away that cone from the top. Now here there are quite a few lengths that are important. We not only have the radius of the base, but there is also now what should I call it? Should I call it capital R? The radius of the top part. In fact, let's switch those because the bigger one, to me, the bigger one should be capital. Why not? It makes a little bit more sense. Okay, and we also have two heights. We have the height of the smaller cone, which is this one, and the height of the bigger cone, which is actually this full height, not h. H is actually the difference between those two heights. What we end up having to do within this is actually use similar triangles. I'm going to give you an example. Let's say that they've told us that this is 2 centimeters and this is 6 centimeters. And they also tell you that the height of the cone that has been cut out is 4 centimeters. And they have asked us here to find the volume of the frustum that is left. Now, if we just look at these triangles here, they are actually similar triangles, and I can draw them out separately. It's as if we have this situation. Now, I knew that wasn't going to go across. Apologies about that. So let me just get rid of that little sticky out bit there. And it goes across there. We have a triangle that looks like this, with this distance being 2, this distance being 6, and we're told this distance here is 4. And we've been asked to find the volume of this frustum, so we're going to have to know what x is, or what the height of this bit is. Our two similar triangles here are actually the little one, where we have 2 and 4, and the big one, where we don't know how long this big side is, but we do know that the bottom is 6. So let's recap with our similar triangles from before. Let's use the pair of values that we know to find our scale factor. We can see that the larger shape is 3 times larger than the smaller shape, and therefore what we do is we times this 4 by 3 to get 12. So this full length here is going to be 12, and therefore it must make this x value here equal to 8 centimeters. So now I know everything that I need to know about this shape to work out the volume. The volume in this case will be equal to the volume of the large cone minus the volume of the small cone, because we take away that volume. Gosh, they're really bad cones, aren't they? Sorry about that. The volume of the large cone, remember that the volume of a cone is given by 1/3 pi r squared h. So in this case, it's going to be 1/3 pi. Now the radius of the large cone is 6, so 6 squared times its height. Now its height is not 8, it's 12, right? So the large cone originally had a height of 12, so we times that by 12. And we take away the volume of the small cone, which is 1/3 pi. Now its radius is 2, so it'll be 2 squared times its height, which is 4. And working this out, we end up with, so 36 times 12 divided by 3. So we end up with 144 pi minus 4 over 3, 16 pi over 3. And we end up with this fairly horrible number of 416 over 3 pi. But if we press S to D here, I end up with 435.6 or 436, and it will be centimeters cubed, would be the volume of that frustum. So you can see here that these questions are a little bit tricky. You have to also think about similar triangles. Do not be afraid to draw as much as you like. You can see how many diagrams I've added to this one. But these shapes are made from cutting away other shapes from them. So you just have to think logically. Feel free to write out equations like this for the examiner to show them what you think you should do. So even if you don't know how to apply it, write out things like that to say, well, I know I would get the volume from the large one minus the small one. And then the method might come to you as you start writing things down. But you do get marks for stages like that to show that you understand the logic. Okay, really, really well done. So next, have a go at some of the questions, see how you get on. If you get stuck with any of them or want to check your answers, there's a work solutions video at the bottom of the page.